So at the end of the last video, we saw that it's not necessarily possible that, or it's not always possible that just because a function is continuous at a point, that it's going to be differentiable at a point. And we said that there are several ways that a function can fail to be differentiable. Now remember that differentiable just means, you always have to go back to what these words mean all the time, just means that we can't find the slope of our tangent line. And so there's lots of different ways to actually go ahead and figure this out. Notice that if I ever had a function that maybe had, at a particular point in time, a vertical tangent line, the slope of a vertical tangent line is undefined. So here I can see that the slope is undefined, which means that f prime of a does not exist, right? So this would be a time when I could have a function that, even though it's connected, could fail, again, to be differentiable. If I take a look down here, or next at part B, if I have a discontinuity in my graph, that's going to cause a problem. Remember, I can't be differentiable here at this point A, because if I was differentiable there, the above theorem would have told me that the graph was connected. Now, part of the reason why this is the case is that, keep in mind that at this point, I kind of have a tangent line here to the graph that kind of moves in the same direction. I could kind of almost imagine a tangent line up here that moves in the same direction. And I don't know, it's kind of hard because at this point I could probably almost imagine multiple tangent lines, all kind of moving roughly in the same direction as the curve. So really what I have here is that I have too many kind of different pieces to consider, and I could say here that the curve really has no direction at this point. And so f prime of a does not exist. The last way we already talked about was kind of like in an absolute value function where I have a corner point. So sharp corner points are sometimes functions that create cusps, like maybe a function that does something like this. That's still a sharp corner down there. Is again not going to allow the graph to have a clear either direction at that point, or it's going to create a slope that's undefined. In this case, we can see that we could actually create tangent lines that kind of can come at this point from multiple directions. And so again, I can state here that the curve has no direction at this point, right? It kind of has multiple directions. And so again, f prime of a does not exist. So these are really great kind of visual cues for when I would come across a function that I can definitely tell right from the picture is not going to be differentiable at a point. Corner points or cusps, discontinuities, or spots where there might be vertical tangent lines. The vertical tangent lines are probably the hardest ones to spot, but these other two are typically very, very simple and straightforward.